Okay, picture this. You're holding a tiny little object right in the palm of your hand. It weighs just 1 single kilogram. Now, I want you to imagine a massive freight train pulling an absolute mountain of black, heavy coal. We're talking 60 tons of it. What if I told you that the tiny object in your hand holds the exact same amount of potential electricity as that entire mountain of coal? Sounds completely like science fiction, right? Well, it's actually not. It is pure established science, and it all revolves around this incredible concept of energy density. Welcome to this explainer where we're going to unpack exactly how this mind-bending science is becoming a reality. Today, we are focusing on a monumental project taking shape in Ishwardi, Pabna, the Rooppur Nuclear Power Plant. It's an absolutely massive leap toward national energy security and carbon reduction. And we are about to demystify the science, the scale, and the safety behind this huge energy milestone. Okay, let's dive into this. Here is our roadmap for today. Number 1, Rooppur's energy future. 2, how nuclear works. 3, why it's important. 4, state-of-the-art safety. 5, plant versus bomb. And finally, 6, waste and the future.
Section 1. Rooppur's energy future, a milestone for Bangladesh.
Moving on to Section 2, how nuclear works. The science of the invisible atom. So the entire process hinges on one fundamental scientific concept, nuclear fission. Nuclear energy is literally the immense power trapped inside an atom's tiny nucleus. By taking a heavy atom like uranium-235 and basically striking it with a neutron, that atom splits right down the middle, releasing a staggering amount of stored energy. Now, you might be wondering, how exactly does a microscopic, invisible splitting atom actually turn on the lights in your living room? Well, it's basically a 3-step chain reaction. Step 1, that splitting uranium-235 generates an intense, extreme amount of heat. Step 2, that heat is immediately used to boil water, which creates highly pressurized steam. And Step 3, that steam is channeled to spin a massive turbine connected to a generator. Just like that, heat becomes the electricity that powers our grid. Section 3, why it's important. The power of energy density. And this brilliantly illustrates exactly what we talked about at the very beginning. The energy density here is truly staggering. Just 1 kilogram of uranium fuel matches the energy output of 60 tons of coal. That means drastically less raw material to extract, transport, and physically burn just to generate power. It's efficiency on a totally different scale. But efficiency isn't the only benefit here. Rooppur provides what we call baseload power. Unlike solar or wind, which obviously fluctuate based on the weather, nuclear provides a steady, uninterrupted green energy supply 24 hours a day, 365 days a year. And crucially, operating a nuclear plant emits 0 greenhouse gases, making it an incredibly powerful tool for our climate strategy. All right, Section 4, state-of-the-art safety, built to international standards. Now, with great power comes the need for incredibly great safety. Rooppur uses Generation 3 Plus VVR 1200 reactors. Now, what's really interesting about this is how these features protect us even if the facility completely loses electricity. First, there's the core catcher. It's a subterranean trap designed to catch molten material if the fuel ever melted, ensuring it never breaches the earth. Next is passive safety, meaning without any electricity at all, the reactor cools itself using natural gravity and air pressure. And finally, the double shield encases the whole thing in reinforced concrete that can literally survive extreme earthquakes or direct plane crashes. Section 5, plant versus bomb, busting myths with science. Okay, let's address the elephant in the room. It's a question that naturally crosses people's minds. Can the Rooppur power plant explode like a nuclear bomb? Look, it's a completely valid fear, mostly fueled by pop culture and movies. But what does the undeniable science actually say? So the crucial point is that the difference here is entirely about fuel concentration. A nuclear bomb requires highly enriched uranium. We're talking over 90% purity just to achieve an explosive chain reaction. The fuel used at Rooppur contains only 3 to 5% uranium. Scientifically, physically speaking, it is absolutely impossible for this low-enriched uranium to cause a bomb-like explosion. It can only produce controlled heat. Section 6, waste and the future. Answering your final questions. Let's do a quick rapid-fire Q&A on some logistical concerns. What happens to the waste? Well, under the agreement, Russia actually takes back all of the used fuel, meaning no permanent radioactive waste stays in Bangladesh. What about the Padma River? Yes, its water is used for cooling, but it runs in a completely separate closed-loop system. It literally never touches radioactive materials. Plus, those 4 massive cooling towers safely condense the hot steam right back into water.
And what about the return on this massive investment? It really revolves around one baseline number, 60. The plant is designed to provide uninterrupted electricity for at least 60 years. And with proper maintenance, that lifespan can be extended all the way up to 80 years. That is a massive long-term return on investment.
Let's move to and see how this builds out on a timeline. The excitement starts in 2026, when the first unit is expected to start supplying the national grid. Fast forward, and it powers the nation consistently until 2086, completing that initial 60-year lifespan. And potentially, it just keeps on running all the way to 2106. By completing this project, Bangladesh is officially stepping onto the global stage as the 33rd nation in the world to utilize nuclear power. We've explored the science, the incredible safety features, and the unmatched efficiency of turning a tiny handful of fuel into an ocean of electricity. So I'm going to leave you with this final thought to ponder. When a nation gains access to decades of uninterrupted, clean baseload energy, it changes everything. How will this new era of limitless power transform the economy and the daily lives of the people for the next century? Think about the possibilities. Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll catch you on the next one.